Key concept 7, target D.
Yeah, YouTube channel is at Math Videos by Mr. A. Make sure you subscribe so that way you know when new videos come out. Hit the notification button as well. I'll be making videos for Key Concept 6 through Key Concept 14 for Integrated Math 1 Core and Honors.
Use the following partially completed proof for questions 19 and 20. Okay, so we just need to fill in the blanks for 19 and 20. We're going to start the proof from the very beginning and sort of work through it. We always start a proof of what's given, so we're given that quadrilateral goat is a parallelogram. Remember, quadrilateral just means a four-sided figure. So that's what we would want to put as statement number 1, and our reason would be because it's given to us. Okay. Now, you'll notice in statement 2, there's a blank, and it says that's the answer for question 19. The reason that goes with it is definition of parallelogram. If you look back through your notes and you look at the properties of parallelograms, I believe it was property A, which said that opposite sides of a parallelogram are parallel, hence the name parallelogram. Okay, so opposite sides are parallel. So for question number 19, we're going to go with the top side, which is OA. It's going to be parallel to the bottom side, so GT. Okay, remember, opposite sides are parallel. So top with the bottom, left with the right. The left side is called OG. It's going to be parallel to the right side, which is AT. By definition, a parallelogram. Now, statement number 3. First thing we're told is that OAG is congruent to TGA. And we're talking about angles there because it has the angle measure. So angle OAG, if you trace it out, OAG is really angle A in the middle, so we'll put one arc, and then I'm going to put a little a and circle it to let me know that what I'm talking about are congruent angles here. It's congruent to angle TGA, so again, tracing that out. Use a different color this time. TGA, angle in the middle is G, one arc, and then I'm putting a smaller a, circle it to let me know I'm talking about congruent angles, okay? Next piece of information we're given there is angle AOT is congruent to angle GTO. So AOT, starting with A, going to O, and then T is really angle O. So we'll do two arcs, put an A, circle it, to let me know that we're talking about congruent angles. Is congruent to angle GTO. So GTO, angle in the middle is really T, so two arcs. Put down an A because we're talking about congruent angles, right? And those are, the reason for that is alternate interior angles are congruent. So they're both on the interior and they're on opposite sides. Next, we're told that OA is congruent to GT. OA is this top side right here. So because we're talking about a side, we'll put one tick mark and an S to let me know that we're talking about congruent sides. It's congruent to GT, which is this bottom one. We'll put one tick mark, put an S to let me know that we're talking about congruent sides, okay? You'll notice that we're talking about sides that are opposite to each other. The top is opposite to the bottom. So if you go back to your notes and you look at the properties, there's only one that says that opposite sides are congruent. So reason number 4 will be opposite sides of a parallelogram are congruent. Okay. The last statement that you make always should be what you're trying to prove. We're trying to prove that the top triangle, or sorry, the bottom triangle GTE was congruent to the top angle, or sorry, the top triangle AOE. So that'll be the last statement we make, and sure enough, it is. And then out of the methods, we're looking at A, S, A, and sure enough, that's the last reason that they gave us. Number 21, LMOP is a parallelogram. If the measure of angle PLM is 97 degrees, then the measure of angle LMO is equal to what? Okay, so they give us angle PLM is 97. So if we trace it in the exact order they give it to us, PLM, the one in the middle is actually L. So what they're really talking about is angle L, and they tell me that it's 97 degrees. They want us to find the measure of angle LMO. So again, tracing that in the exact order that we see. LMO, the one in the middle, is M. So they're really trying to figure out what angle M measures. Notice those two angles are next to each other. So if you go back to your properties, angles that are next to each other are also known as consecutive angles. And consecutive angles are supplementary. Okay? So in a parallelogram, consecutive, it's an extra C there. Consecutive angles are supplementary. Okay. Remember, consecutive means next to each other, one right after the other. And the supplementary just means that they add up to 180. So angle L plus angle M, which is the one they want, should equal to 180. Now, the nice thing about this is we already know what angle L is because they gave it to us. They told us it was 97 degrees. Plus angle M is equal to 180. So if I want to go ahead and figure out angle M, all I need to do to both sides is to get rid of this positive 97, and the opposite would be to subtract 97 from both sides. Okay. So on my left, this will cancel out. You can bring down angle M equals, and then 180 minus 97. 0 minus 7 is impossible. Take one from the neighbor. 8 becomes 7. The 0 becomes a 10. 10 minus 7 gives us 3. We can't do 7 minus 9, so again, we got to take from the neighbor. 1 becomes 0. The 7 becomes 17. And 17 minus 9 will give us 8. So angle M, also known as angle LMO, is going to be 83 degrees. Final answer. 22. Game is a parallelogram. Find the value of x. Okay. Now you'll notice that there's x here and here. Okay. If they're asking us to solve for a variable, that means we need to set up an equation. If we're going to set up an equation, that also means that we need to find two things that are equal to each other. Now, we're talking about this angle right here and this angle right here. Okay. If we were to shape up this image, you would notice that both of those angles are in the interior, also known as the inside. And they happen to be in completely opposite sides. So this top one is on the top right. This bottom one is on the bottom left. So they're alternate interior angles. Okay. Now, when we're talking about a parallelogram, alternate interior angles are congruent. So we'll set up our equation. This angle down here is going to be called GEA. So angle GEA is congruent to the top one, which is going to be EAM. EAM. Now, wherever we see GEA, we're going to replace with the bottom angle, which is 2x plus 23. Now notice I didn't write it with parentheses anymore because technically there's no value out front that we can see, which means that there's a positive 1. And multiplying by a positive 1 won't change anything. Wherever we see angle EAM, we're going to replace or substitute with the quantity 5x minus 13. Okay. Now, our goal is to solve for solve for x, so we need to solve this equation. Step 1 is distributive property, but we no longer need it because there's no more parentheses. Step 2 is to combine like terms. If you cover up the right side completely, on the left, we cannot combine 2x and 23 because one has a variable, the other one's a constant. If you cover up the left, on the right side, 5x and minus 13 cannot be combined because, again, one has a variable, the other one's a constant. So we can move on to step 3, which is to add or subtract. Dealing with my x's first, we want to get them where they're bigger. 5x on the right is bigger, so we want to get this positive 2x to go to the right. So we're going to do the opposite. We're going to do the inverse operation, which is subtract 2x from both sides. On my left, 2x minus 2x will eliminate. We can bring down a positive 23, bring down the equal sign. On the right, 5x minus 2x is 3x. We haven't done anything to the minus 13, so we're going to go ahead and bring that straight down. Notice what I accomplished in that step was getting all my x's to the right. So now I want to get my constants to the left. So we're going to get rid of the minus 13 by adding 13 to both sides. Okay. On my left, 23 plus 13 is going to go ahead and give me 36. On the right, minus 13 plus 13 cancels, bringing me a 3x. variables on one side, constant on the opposite. Last step is to divide and multiply. Right now, x is being multiplied by 3, so the opposite would be to divide both sides by 3. On the left, 36 divided by 3 is going to give us 12. On the right, 3 divided by 3 is 1, so we just bring down the x. Our goal was to find the value of x. We did, so x equals 12 is the final answer. Number 23, determine the value of y that would make the figure below a parallelogram. Okay. So again, directions this time are to find the value of y. We see y here, we see y here. We know they're angles for 2 reasons. 1, they're in the corner. 2, they have a degree symbol. Now, these angles are not opposite to each other, they're next to each other, also known as consecutive. Okay? So if you remember from your properties, consecutive angles are supplementary. Consecutive angles are supplementary. Remember, consecutive is just a fancier way, expanding our vocabulary a little bit, to say next to or one right after the other. These 2 angles are right next to each other. Supplementary means that they add up to 180. So the equation I'm going to set up, and the reason I have to set up an equation is because we want to find y, which is a variable. In order to solve for a variable, you need to first set up an equation. So we're going to take the top angle, which is 2y plus 5. We're going to add the bottom angle to it, the one that was next to it, 8y plus 35, and that's all equal to 180 degrees. That's what it means to be supplementary. Okay. Step 1 is distributive property. There are parentheses. Now, there's no value in front that we can see, but we know that there is a positive 1 in front of both of them. Multiplying or distributing, doing distributive property by 1, a positive 1, won't change anything. So we can just go ahead and bring down the entire equation without parentheses. And again, we're only allowed to do this because what is out front is a positive 1, and multiplying by positive 1 does not change the value. Step 2, combine like terms. On my left, first thing I see is a 2y. It's positive. Anything else with the y, positive 8y. And then we're going to box up 5, which is a constant. Box up 35, which is also constant. Notice I didn't box up 180 because although 180 is a constant, it's on the opposite side of the equation. Okay? Combining circles, 2y plus 8y will give me 10y. Now the squares, 5 plus 35 will give me 40, and that's still equal to 180. Okay? Step 3 is to add or subtract. All my variables, all my y's are on the left side, leave them there. I want to get rid of the constant 40 to the right, so it's positive, so I'm going to subtract from both sides. On my left, 40 minus 40 is 0, so I can bring down 10y equals, on the right, 180 minus 40 is going to give us 140. Okay? Variables are on the left, constants are on the right. The last step is to multiply or divide. This is 10 times y, so to undo the multiplication by 10, I'm going to divide both sides by 10. Okay? 10 divided by 10 is 1, so we can bring down the y. On the right side, 140 divided by 10 is going to give us 14. Now, directions were to determine the value of y, which we did. So we're going to go ahead and say that our final answer is that y is equal to 14. Number 24, determine the values of x and y that will make the figure below a parallelogram. Okay, so they want x and they want y. Again, they're asking for variables, which means we're going to have to set up equations, most likely an equation per variable. Okay, the only places I see x is up top here on the line segment AB, and on the bottom on the line segment DC. Those are sides. Okay, the way I know that is because they're actually on the side and there's no degree measure. And these 2 actually happen to be opposite to each other. So, opposite sides of a parallelogram are congruent. Opposite sides of a parallelogram are congruent. Okay? The top is AB. The bottom is DC. Okay? The fact that they're congruent means that they're the same length. So wherever I see AB, I'm going to replace with the quantity 2x minus 6 equals, wherever I see the DC, I'm going to replace with the quantity x plus 7. Alright, step 1, distributive property is not necessary because there's no parentheses. Step 2, combine. I cannot combine on the left because there's just a 2x and a minus 6, variable and constant. If you cover up the left, on the right side, it's the same exact thing. Variable, constant, I cannot combine. So step 3 is to add or subtract. I want to get all my x's on one side. Now, on the left, we can see the 2x. On the right, there's just an x, but we know that the coefficient, that the number out front is a 1, which means 2x is actually bigger. So I want to get all my variables to the left. I want to get this positive 1x to join it, so I'm going to subtract 1x from both sides. Okay. On my left, 2x minus 1x is just 1x. We don't need the 1 in front, so we'll just call it x. We're going to bring down the constant minus 6 equals, on the right, 1x minus 1x eliminates, we can bring down the positive 7. Okay. So what we accomplished in that one step is to get all the variables on the left. Now I want to get the constants to the right. So I want to undo the minus 6 by adding 6 to both sides. On my left, negative 6 plus 6 is 0. I can bring down the x. On the right, 7 plus 6 is going to give us 13. One of our goals was to find x. We did. So one of our final answers will be x is equal to 13. Now, we need to still find y. We see y right here and right here. Okay? It's drawn on the diagonal AC. Remember, a diagonal is a line drawn from one corner to the complete opposite corner of a shape. One of the properties of a parallelogram is that diagonals bisect each other. So before, we had the line segment AC, but it was bisected. So that means it was cut in half. So when we drew the other diagonal, it cut it in half. So that means this new segment AE is actually going to be the same length as the line segment AC. Okay, so we have AE, which is this one right here, is going to be congruent to EC, which is that one down there. Okay, that's going to be the equation that we are able to set up. Now, wherever I see AE, I'm going to replace with 9y plus 3 equals, wherever I see EC, I'm going to replace it with the quantity 6y plus 12. Okay, I'm running out of space, so you're going to see, once I get to the bottom of this slide, I'm going to move over to the right a little bit. Now, distributive property is not necessary because there's no parentheses. We cannot combine like terms because on the left, 9y has a variable, 3 is a constant. On the right, 6y has a variable, 12 is a constant. So we move on to step 3, adding or subtracting. We want to get the variables, the y's, wherever they're bigger. 9y on the left is bigger, so I want to move this positive 6y to the left. So to undo that, I'm going to subtract 6y from both sides. On my left, 9y minus 6y is going to give me 3y. We can bring down the positive 3 equals. On the right, 6y minus 6y eliminates. We can bring down the positive 12. Okay. Now, we got all the variables to the left. We want to get the constants to the right. So we want to undo the plus 3 by subtracting 3 from both sides. Okay. And this is where I'm going to start writing in green now just to separate the work. I'm going to move over a little bit just because I ran out of space. Okay. On the left, 3 minus 3 will cancel, which will leave me just 3y equals. On the right, 12 minus 3 is going to give me 9. Now, we finish adding and subtracting. We need to multiply and divide. This is 3 times y. So to get y by itself, we're going to do the opposite, which is divide both sides by 3. On my left, 3 divided by 3 is 1, so I'll bring down the y. On the right, 9 divided by 3 gives me 3. Okay. Keep in mind, our task was to find x, we did, and to find y, which we did. So final answers will be x equals 13, and y is equal to 3.